Circles. In the previous chapters, we have explored a variety of functions which could be combined to form a variety of shapes. In this discussion, one common shape has been missing, the circle. We already know certain things about the circle, like how to find area and circumference and the relationship between radius and diameter, but now, in this chapter, we explore the circle and its unique features that lead us into the rich world of trigonometry. To begin, we need to find distances, starting with the Pythagorean Theorem, which relates the sides of a right triangle. We can find the distance between 2 points. Pythagorean Theorem. The Pythagorean Theorem states that the sum of the squares of the legs of a right triangle will equal the square of the hypotenuse of the triangle. In graphical form, given the triangle shown, a squared plus b squared equals c squared. We can use the Pythagorean theorem to find the distance between 2 points on a graph. Example 1. Find the distance between the points -3, 2 and 2, 5. By plotting these points on the plane, we can then draw a right triangle with these points at each end of the hypotenuse. We can calculate horizontal width of the triangle to be 5 and the vertical height to be 3. From these, we can find the distance between the points using the Pythagorean theorem. Distance squared equals 5 squared plus 3 squared equals 34. Distance equals square root of 34. Notice that the width of the triangle was calculated using the difference between the x input values of the 2 points, and the height of the triangle was found using the difference between the y output values of the 2 points. Generalizing this process gives us the distance formula. Distance formula. The distance between 2 points, x sub 1, y sub 1, and x sub 2, y sub 2, can be calculated as distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Try it now. Find the distance between the points 1, 6, and 3, -5. Circles. If we wanted to find an equation to represent a circle with a radius of r centered at a point hk, we notice that the distance between any point xy on the circle and the center point is always the same, r. Noting this, we can use our distance formula to write an equation for the radius. R equals square root of x minus h squared plus y minus k squared. Squaring both sides of the equation gives us the standard equation for a circle. Equation of a circle. The equation of a circle centered at the point hk with radius r can be written as x minus h squared plus y minus k squared equals r squared. Notice that a circle does not pass the vertical line test. It is not possible to write y as a function or x or vice versa. Example 2. Write an equation for a circle centered at the point -3, 2 with radius 4. Using the equation from above, h equals -3, k equals 2, and the radius r equals 4. Using these in our formula, x minus 3 squared plus y minus 2 squared equals 4 squared. X plus 3 squared plus y minus 2 squared equals 16. Example 3. Write an equation for the circle graphed here. The circle is centered at the origin, the point 0, 0. By measuring horizontally or vertically from the center out to the circle, we can see the radius is 3. Using this information in our formula gives x minus 0 squared plus y minus 0 squared equals 3 squared. X squared plus y squared equals 9. Try it now. Write an equation for a circle centered at 4, -2 with radius 6. Notice that relative to a circle centered at the origin, horizontal and vertical shifts of the circle are revealed in the values of h and k, which are the coordinates for the center of the circle. Points on a circle. As noted earlier, an equation for a circle cannot be written so that y is a function of x or vice versa. To find coordinates on a circle given only the x or y value, we must solve algebraically for the unknown values. Example 4. Find the points on a circle of radius 5 centered at the origin with an x value of 3. We begin by writing an equation for the circle centered at the origin with the radius of 5. X squared plus y squared equals 25. Substituting in the desired x value of 3 gives an equation we can solve for y. 3 squared plus y squared equals 25. Y squared equals 25 minus 9 equals 16. Y equals plus or minus the square root of 16 equals plus or minus 4. There are 2 points on the circle with an x value of 3, 3, 4, and 3, negative 4. Example 5. Find the x-intercepts of a circle with radius 6 centered at the point 2, 4. We can start by writing an equation for the circle. X minus 2 squared plus y minus 4 squared equals 36. To find the x-intercepts, we need to find the points where y equals 0. Substituting in 0 for y, we can solve for x. X minus 2 squared plus 0 minus 4 squared equals 36. X equals 2 plus or minus the square root of 20 equals 2 plus or minus 2 multiplied by the square root of 5. The x-intercepts of the circle are 2 plus 2 square root of 5, 0, and 2 minus 2 square root of 5, 0. Example 6. In a town, Main Street runs east to west and Meridian Road runs north to south. A pizza store is located on Meridian 2 miles south of the intersection of Main and Meridian. If the store advertises that it delivers within a 3-mile radius, how much of Main Street do they deliver to? This type of question is one in which introducing a coordinate system and drawing a picture can help us solve the problem. We could either place the origin at the intersection of the 2 streets or place the origin at the pizza store itself. It is often easier to work with circles centered at the origin, so we'll place the origin at the pizza store, though either approach would work fine. Placing the origin at the pizza store, the delivery area with radius 3 miles can be described as the region inside the circle described by x squared plus y squared equals 9. Main Street, located 2 miles north of the pizza store and running east to west, can be described by the equation y equals 2. To find the portion of Main Street the store will deliver to, we first find the boundary of their delivery region by looking for where the delivery circle intersects Main Street. To find the intersection, we look for the points on the circle where y equals 2. Substituting y equals 2 into the circle equation lets us solve for the corresponding x values. X squared plus 2 squared equals 9. X equals plus or minus the square root of 5, which is approximately plus or minus 2.236. This means the pizza store will deliver 2.236 miles down Main Street east of Meridian and 2.236 miles down Main Street west of Meridian. We can conclude that the pizza store delivers to a 4.472 mile long segment of Main Street. In addition to finding where a vertical or horizontal line intersects a circle, we can also find an arbitrary line intersects a circle. Example 7. Find where the line f of x equals 4x intersects the circle x minus 2 squared plus y squared equals 16. Normally, to find an intersection of 2 functions f of x and g of x, we would solve for the x value that would make the functions equal by solving the equation f of x equals g of x. In the case of a circle, it is impossible to represent the equation as a function, but we can utilize the same idea. The output value of the line determines the y value. Y equals f of x equals 4 of x. We want the y value of the circle to equal the y value of the line, which is the output value of the function. To do this, we can substitute the expression for y from the line into the circle equation. X minus 2 squared plus y squared equals 16. 17x squared minus 4x minus 12 equals 0. Since this quadratic doesn't appear to be easily factorable, we can use the quadratic formula to solve for x. X equals 4 plus or minus the square root of 832 divided by 34, or approximately 0.966 or negative 0.731. From these x values, we can either use equation to find the corresponding y values. Since the line equation is easier to evaluate, we might choose to use it. Y equals f of 0.966. Y equals f of negative 0.731. The line intersects the circle at the points 0.966, 3.864, and negative 0.731, negative 2.923.